Hi guys, and welcome to another practice question solution video for volume and capacity. Now remember, you could find the image for these questions on our Facebook page and on our website. I'll put the links to those two things in the description box below. So let's look at this question. Here we have A and B, and they are two rectangular containers. They told us that the water level in container A is 5 times that of the water in container B. Okay, and then they told us that Keith poured some of this water from container A into container B until the water level in both containers are of the same height. Now let's look at some of the vocabulary in this question. 5 times would mean that whatever this level here, okay, is 5 times the level in container B. So if this represents one level, then this one is 1, 2, 3, 4, and 5 times this level here. The next thing we need to understand is that the water level that they are talking about in relation to these two containers is the height. Alright, we have height here and we have this height here. This height, since we are dealing with volume, okay, this height, if we are using the formula for volume, we would have a length times a breadth or width and a height. Okay, so every time we talk about water level, we are talking about the height of the water. Now let's see. They ask us to find the volume of water in container B. So we want to find this original volume here. So this is one formula that we know for volume. Another formula that we know for volume is area or base area multiplied by some height. Now area is just two lengths multiplied together. Okay, so we were given the area of the 50 of A. Okay, so the volume of water in A would be equal to this base area, 50 centimeters squared, multiplied by the height given, which is 66 centimeters. This will give us a volume of water in container A as 3,300 centimeters cubed. Now they told us that this volume is 5 times what is in container B. So let's write that statement. The volume in A is 5 times the volume of water in container B. Let's put in the figures. The volume in container A is 3,300 centimeters cubed, 5 times the volume in B, which we do not know, and which is what we want to find. From our previous lessons and our previous practice questions, we talked about, to find this unknown here, we would move this on the other side of the equal sign. And when we do that, we change the operation to its inverse. So if we are multiplying by 5 here, on this side of the equal sign, we will divide by 5. This will give us a numerical value of 660 centimeters cubed. Alright, and this will be equal to the volume, original volume of water in container B. So your answer to part A is 660 centimeters cubed. Now let's take a look at part B. Part B is asking you to find the increase in water level, right, of container B. Now this increase comes after we add some water from A into B. We will have some new level of water in here, right? We want the increase in height, which is not the new height, but the difference between the new height and the old height of water. Okay, so this here is what we're trying to find, the increase in water level. All right. So if we were to add these two containers together, our total base area would be 50 centimeters squared plus 30 centimeters squared. Now what is the total volume of water in here? Let's try to find that. So the total volume of A and B is, well, we found A here is 3,300 centimeters cubed, and we found the volume of B, which is 660 centimeters cubed. This will give us a total volume of water in both containers, 3,960 centimeters cubed. So let's look at what we have. Keeping in mind the formula for volume. Okay, we have a total area. This total base area here, 50 plus 30, will give us 80 centimeters squared. So we have an area and we have a total volume. So we have a total area and a total volume. Now let's try to find what this height is. Volume, we know, is this, right? The volume of A and B. The area is 80 centimeters squared and multiplied by some height, okay, which is what we don't know. Now this height here in B will be the total height. All right, so let's look at what H is, our height. So again, we would want to move this across to the other side of the equal sign. It becomes division. The operation becomes division, right? We will get a value of 49.5 centimeters as our height. Now that's not what the question asks, right? The question asks you to find the increase in water level. So knowing that, we could find the new volume of container B because we have the new height and the area of B will stay the same. So the new volume will be this base area multiplied by the new height. So the new volume of water in P is 1485 centimeters cubed. Now we are finding the volume to help us find the difference in heights. Okay, now let's find the difference in volume. The difference between the new volume and the old volume, okay, or the increase in volume of water of P is this new volume minus the old volume or the original volume, and this should give us 825 centimeters cubed. Okay, 825 centimeters cubed. Now that we have the increase in volume and we know the base, all right, will always remain 30 centimeters squared, right? So the volume here is 825, and we need the new height. We would move this across here. We will divide by the 30 because we'll be multiplying on this side, so we divide on this side, and this will give us 27.5 centimeters, and this is a difference or your increase in height, 27.5 centimeters.